So now that I've shown how to enter inputs into the different input pages and also check the inputs using the image which is displayed, you can now look at the results for your connection. So you've already noticed that some results have been summarized on the right side of the screen. And if you want to make this bigger, you can always drag the results side to be bigger, depending on whether you want to play with the inputs or view results. But it's actually better to go to the See Detailed Results button here to see more detailed results. So here you can see the summary of connections. You can see that there is an X, Y, and in-plane bending connection component within this overall connection. And that means that there are different connection types which make up the overall connection free body diagram. And you can see these different free body diagrams for each connection type here, where you can see for the X connection, connection number 1, this is the free body diagram, which makes an X connection. So you have the branch force balanced by a vertical reaction on the cord. You have connection 2, the Y connection, where you have the branch force balanced by cord shear. And then you have the in-plane bending connection, where obviously the in-plane bending is balanced by a bending moment on the cord. And all the cord reactions right now are on the left side of the cord, because this is where we've defined all our forces. So the program for now is just assuming that this right end here is free. And this is also where it's valuable to check the assumptions in the program using these images. Here we would have any errors and warnings as we do on the normal connection input page. Then here we can see all the limit states that the program checks for this connection for each connection type. So we can see that for in-plane bending, for the X connection and the Y connection, it checks cord plastification, cord shear yielding, and branch local yielding. And each connection type has a different utilization ratio associated with it, depending on the load on the branch and also the connection resistance for this connection type. We then also have the governing cases, which is just the worst case scenario for each connection type. So we have the worst utilization ratio out of the in-plane bending connections, the Y connections, and the X connection types. And then the total utilization ratio is just the sum of the governing cases. You can also view a calculation sheet for this connection, where it has everything written out with all the formulas and how it's done all the analysis for this connection. So I'll start by showing you the constituent free body diagrams, once again starting with the X connection. It will define the member properties which are used in in each connection type. So we'll tell you all the different geometric properties of the section which you selected. And this is good for cross-referencing the geometric properties of the built-in sections. It'll define some connection-specific parameters. Then you get your free body diagrams again with your equations of equilibrium. Here, all the limits of applicability are checked, and you can see all the limits written out symbolically, and then whether your connection passes or not, and you can see all the numbers subbed in as well. It repeats this process for the Y connection, and also for the in-plane bending connection. And then it gets into the capacity checks, where it analyzes the resistance of your connection for each constituent free body diagram. So where applicable, it'll calculate the cord stress function, which might need to be applied to different connections. And then it will check each limit state, which we previously saw. It will show you the equation for that limit state resistance, and then the associated utilization ratio. And does this for each connection type. And then at the bottom, again, you have a summary of the maximum utilization ratio for each connection type. So these are your governing limit states, and then your overall utilization ratio. You can see here how all units are in kilonewtons and millimeters. Well, millimeters for the area, but kilonewtons here, and then we have kilonewton meters here. That's because of the units we selected in the inputs page. And you can see that if we go to our other connection, where we have this connection here, we're now using imperial units. So now, if we go over to the calculation sheet, you can see that everything is now in imperial units. We have the height and width in inches. If we go down, we have kips and feet based off the units we defined, and it's a very similar format otherwise to the original calculation sheet that I showed for the one branch connection.